All right. Good morning or afternoon or whenever you're watching this. This is the first of 3 lessons that will basically be the big meat of stoichiometry. So the purpose of what we've been doing with all the unit conversions and the balancing equations, all of this is leading up to these next 3 lessons. The purpose here is that we are trying to figure out how much we would need to measure out of some reactant to make a certain amount of product. So the purpose of this is you might be assigned to create 15 grams of this. Well, in order to make 15 grams of sodium oxide, you would need to know how much sodium and how much oxygen you would need to react to do that. And so we have to do these calculations to figure out what measurements we need to make. So when I'm designing labs for you all, I'm looking at these measurements and making sure you get an amount that will fit in your container, in your test tube, or in your beaker. And so I have to do these calculations before to figure out exactly how much you should be reacting. If we were having class like normal, we'd be doing this in the lab, we'd be practicing, we'd be seeing when we make too much or not have enough. We're just going to do the math part right now because that's what these standards require us to do. So I will look into doing some sort of lab you can do at home, but no promises it'll be any good. I'm working on that. Anyway, the last few lessons you've been converting between particles and moles mass, or moles and grams. You've been converting between moles and moles with mole ratios. And then your last assignment, you were doing a mixed practice where we did a lot of them randomized and you had to figure out which way to go. So as a reminder, this is a roadmap we can use to help us figure out our problems, and I'm going to be using it today for these first couple problems. And as with the other lesson, I'll have a video playlist of the other probably 3 problems. I'll probably save the last 3 problems for you to do on your own. And you can look at that playlist to check your answers, and I'll work through each of those if you need it. But we'll be using this to help guide our problem solving. So if you look at the assignment document on either printed out or copied down, you'll see that the first, it says sodium metal burns as follows, and then has this chemical equation. And it's asking how many moles of O2 are needed to completely react with 9.5 grams of Na. So we need to figure out, if we had 9.5 grams of sodium, how many moles of oxygen would we need in order to react all of that? So we know that we're starting in the they give us 9.5 grams of sodium, and we need to find how many moles of oxygen. So they've given us grams of sodium. We know that that is the mass. That is the mass. We need to figure out how many moles. Now, you'll see that we're not going from grams of sodium to moles of sodium. We're going from grams of sodium to moles of oxygen. So one more thing I'm going to add over here to our graphic organizers. I'm going to put a dotted line separating moles and moles. The reason I'm going to do that is because this side only applies for everything in the same compound, or the same substance. In this case, it's sodium. So this side only applies to sodium. We can go from mass of sodium to moles of sodium in one step. We could go another step further and go from moles of sodium to particles, or how many atoms of sodium we need. But that doesn't tell us anything about oxygen. To go from sodium to oxygen, we'll need to cross this dotted line. We'll need to get a mole ratio from our balanced chemical equation. It's a moles to moles conversion we need. So I'm going to put sodium on that side and oxygen on this side, O2. So I know we're starting off with 9.5 grams, that's mass, of sodium, and I know that we need some number of moles of oxygen. Oxygen's over here with moles, so we're trying to go from mass of sodium over to moles of oxygen. That's going to be a 2-step problem, and I'm going to work these as 2 steps pushed together into one big problem. If this is too much and I lose you with this part, I'll post this. There'll be a second video where I do it as 2 separate problems, but the goal here is to do these as one giant problem and not be doing 2 or 3 or 4 or 5 or 6 of these separate problems that it's going to end up building up to, so that you're saving yourself time. Anyway, so we know we have 9.5 grams of sodium. We don't have much oxygen, So let's write this out. And I'm going to be going across the whiteboards here, so please forgive me when I make the jump, and it sort of visually makes it a little harder to follow. If you need to, yeah. So we are starting off with 9.5 grams of sodium. And because we're going to have to take mass up to moles and over to moles, that's the path of the arrows that we have to follow to get from where we're starting to where we're ending. That's 2 arrows. That's going to tell us that we need 2 conversion factors. So every time we cross an arrow, we cross one of those roads, we need a conversion factor. So that has 2. I'm putting 1 on this board, 1 on this board. Imagine that this is a seamless full whiteboard that I do not have. So to set up this problem, we need to first go from mass to moles. Well, we know that we want grams of sodium to go away, so we put grams of sodium on the bottom. And we're going up to moles with our first conversion, and it's moles of sodium. So I'm going to put moles of sodium up here. Now, as you all should remember, to go from mass to moles, we need the molar mass, which means you need to look up on the periodic table the molar mass of sodium. It turns out that it's 222.99 grams of sodium in every 1 mole. So that is our first conversion factor, and that's that first step right there. This is our second arrow, our second conversion factor. So right here is where we will have our second conversion factor. This time we're going from moles of sodium to moles of oxygen. So we know that moles of sodium has to go on the bottom, so the units cancel out. Those 2 need to cancel out. And we're putting moles of O2 where we're going on top. To figure out the numbers that go in these blanks, we have to look at our balanced chemical equation and plug in the coefficients. So we look for sodium in our balanced chemical equation. Here's sodium by itself. It has a coefficient of 4. So we'll put a 4 with moles of sodium. For moles of O2, we look over here. There's no coefficient. That means it's a coefficient of 1. And so we'll put a 1 up here. Now, we see that grams of sodium cancels out with grams of sodium. At this point, we've got it all set up, and so we can start canceling things out. Grams of sodium cancels out with grams of sodium. Moles of sodium cancel out with moles of sodium. And our last units look like it'll be moles of oxygen. So let's combine all this into one single fraction. Get rid of everything we can cancel out. Make it a little bit neater. So we have 9.5 over on the left. We're multiplying that by 1, which is just itself, so I'm not going to worry about any time we multiply by 1 or divide by 1. It doesn't change the number. We multiply by another one. Again, we'll just, okay, that's the same thing as it was. It's still 9.5. Moles of O2. In the denominator, we have 22.99. Grams canceled out, times 4. Moles canceled out. So that's all we actually have left in our problem, is 9.5 moles of oxygen divided by 22.99 times 4. So let's actually combine this part of the bottom because I don't know if you all have graphing calculators, but you all should have at least 4 function calculators on your phones. So we'll do 22.99 times 4, and the calculator tells me that it's 91.96. So 9.5 moles of O2, and in the denominator we now have 91.96. Now we can take the 9.5 and divide by the 91.96. And that means that we have, when you put it into your calculator, 0.1033 moles of O2. So what we did is we set up our problem using our graphic organizer over here to figure out what our conversion factors we were going to need. We canceled things out and we were left with this math problem right here. We simplified the denominator. We took the numerator, divided by the denominator to get 0.1033, and we're left with that as our answer. The very last thing we need to always do is check for significant figures. We look over at the start, we had 2 sig figs. That means we need 2 sig figs in our answer. So our answer is going to be let's see, here's 1 sig fig and here's a second. 1, 0. Remember that this 0 is a leading 0, and leading zeros are never ever significant. This 0 is a trailing 0 following a decimal, so it is significant. So these are our two sig figs, moles of O2. So that's the first problem. Again, if I lost you setting this part up here, I'll have another video posted where I break that one down a little bit further. But if you're following along and you think you got that, I'm going to do the second problem as another example as well. So you can either pause this and go to the other video, or keep watching and see if it comes together for you more with this second problem. I understand that this is complicated stuff and it's not easy for me to do this through video, so I'm also going to be trying to post samples from the textbook, other videos, other people explaining it. It's very difficult for me to get this across to you remotely, and so try our best here. So, second problem is going to use this exact same chemical equation at the top. I'm going to actually get some of the little notes I made in here. And hopefully do a lot of this. All right. Let's see. What's our second question? Where did it go? Wrong computer. Let's try this one. Nope. Second question. Where are you? There it is. Okay. There we go. So our second question is, how many moles of sodium? That means we want to know how many moles of sodium are needed to produce 12.5 grams of sodium oxide. And this is kind of going to what the whole point of this is if you're a chemist, or this is what you would use it for, you might be told, hey, I need you to make 12.5 grams of sodium oxide. Well, that means you need to figure out, well, how much sodium do I need? And so we need to figure out how many moles of sodium we would need to make what we've been asked to make. We have a recipe, we just need to figure out what the measurement is of our ingredients. And this is how we'll do it. So, that means we're starting with sodium oxide, 12.5 grams, and we look over here on our graphic organizer to help us figure out how this problem's going to go. And we see mass down here. So because I see mass down there and we're using sodium oxide, I'm just going to make a note that this side is going to be our sodium oxide side. So the arrows on this side could take us from mass of sodium oxide to moles of sodium oxide, moles to particles, but if we want to go to a different substance, we're going to have to get a mole ratio and convert moles to moles. We can't just go directly from mass to moles, we have to follow the arrows in our graphic organizer. So that's where we're starting. We know we need moles of sodium. Now we know it can't be this moles of sodium because this moles of sodium is our moles of sodium oxide side. So we need to go from moles of one substance to another substance. These are different substances. So I'm going to make this side sodium. And you can assign these however you want. We're using the ones that we need in our problem. If this was a different problem asking for moles of oxygen, you could say that this side's oxygen. This is just a way of organizing how we're attempting these problems. It applies to all of the problems we'll be doing. And we'll be adding a little bit more in the third lesson of this, or actually the next lesson of this. So we're going from grams of sodium oxide to moles of sodium. So we're going here. And actually, for all the problems you're doing today, you're doing the same thing. You're going from mass to moles to moles. Tomorrow it'll be a little bit different, and the last one will be a 3-step problem. But every one of the ones today, this is actually the same pattern. And so our first conversion factor is going to take us from mass of sodium oxide to moles of sodium oxide. And our second conversion factor is going to take us from moles of sodium oxide to moles of sodium. So let's actually write this problem out now. We know that we are starting with 12.5 grams of sodium oxide. So like all of the mixed practice problems we were doing and the problems we've done so far, we'll start by writing the value they gave us as the start of our problem. And we know we need 2 conversion factors because we have 2 arrows, and I'm going to label them. Arrow 1 will go here, arrow 2's conversion factor will go there. Now, we know we're going from mass to moles, so where we start goes on the bottom, because that'll get the units to cancel out, and where we're going will go on top. And this is an important time to remember to be writing in the chemical formulas. I know they take up a lot of space. I don't have much room to work with, but we need to squeeze them in because we're talking about different chemicals now, and we need to keep track of this. So, to go from mass to moles, we need the molar mass. And figure out the molar mass, I'll do a quick mini lesson over here. So we can calculate it out together. We have 2 sodiums, 1 oxygen. We look up the molar mass of sodium on the periodic table. It's 22.99. We look up the molar mass of oxygen on the periodic table. It's 16. And so we'll take 22.99 times 2, which is 45.98, I believe. Yeah. 1 times 16 is 16. And we add them together. We get 8, we get 9. That's 11, and that looks like a 6 right there. 61.98 is our molar mass. So that's how many grams of sodium oxide are in a mole of sodium oxide. So we go over here. We said it's 61.98 grams of sodium oxide in 1 mole of sodium oxide. That's our first conversion factor. Our second conversion factor, we'll use the arrows over here. So, let's erase this to declutter this just a bit. So our second conversion factor, second arrow. Let me keep that from falling. Okay. We're going from moles to moles. So that means we need moles of, on that side we were working with sodium oxide. On the bottom, moles of sodium on top. To fill the conversion factor, to fill in the numbers, we need to look at our balanced chemical equation. So we have a let's look for sodium oxide. Sodium oxide, Na2O. We look in on the chemical equation. We see there's a 2 with sodium oxide, so we'll put a 2 right here with moles of sodium oxide. We have moles of sodium. We look over at the coefficient on sodium. There's a 4 there, so we'll put a 4 right there. Remember, mole ratios are the only time you will be looking up at that chemical equation and plugging in the coefficients. So, let's see if we can squeeze this in. I will rewrite this just a little bit. Sorry. 4 moles of sodium over 2 moles sodium oxide, and this is step 2. Okay. So, let's look at what cancels out real fast. That'll help us. Let's see, grams of sodium oxide cancels out with grams of sodium oxide. They're on the top and the bottom, they cancel out. Moles of sodium oxide cancel out with moles of sodium oxide. That means all we're left with is 12.5 off on the left there, times, that canceled out, times 1 is still itself, that canceled out, times 4, that's a number we need, moles of sodium, that did not cancel out. In the denominator, we've got 61.98, that canceled out, times 2, that canceled out. Now again, I'm going to solve the denominator. Let's actually solve the numerator and the denominator real fast. So 12.5 times 4 is 50. 50 moles of sodium in the numerator. In the denominator, 61.98, you plug into your calculator, times 2 is 123.96. Now we can take the numerator, the number there, divide it by the denominator, so 50 divided by 123.96 is 0.4034 moles of sodium. And the last thing we need to do now that we've got a nice number, we need to check our significant figures. We look over here in our starting number. We had 3 sig figs. 12.5 is 3 significant figures. We need 3 significant figures in our answer. So let's see. It's equal to 0. That's just leading 0. There's no digits before it. 0.4 is 1 sig fig. 0 is the second sig fig. And 3 is our third sig fig. 1, 2, 3 sig figs. Moles of sodium. So that would be your answer for number 2. So, if you're feeling all right with this, attempt the next 3 problems. There'll be a video playlist as well that you can look through and see me solve those problems. So if you get stuck, you can just click play on those, and we'll walk through it. Hope you all have a good day. Hope you all are healthy. You'll see another video from me tomorrow.